Okay, topic 4.1 video 3. Let's go. The last boundary, transform boundary. The one, San Andreas Fault, right? The one we've been talking about. Watching the video. Asking how far away San Andreas Fault is from us here in Long Beach. Alright, so I decided I gotta figure this out. So, if we look at the San Andreas Fault, basically see where my hand is. It's about right there, kind of moves. Ooh, you can kind of see, I think, that little groove right there. See, where's ooh, there's a 15. Yeah. Ho, 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 ho. See this groove? You kind of see it from here, and then it goes here. Oh. So, let's see. Long Beach, closest. Let's see, just do a path and miles. Start Long Beach. There we go. 51 miles. About 51 miles. I think I guessed 70 today, but no more than 100. We're like 50 miles. See that? Right here. About 51 miles from the San Andreas Fault. Dang, that's not much. So I'm gonna write that here. About, we'll say 50 to 55 miles from Long Beach. Dang, that's a lot closer than I thought. That means even closer, well, to Los Angeles, it's gonna be a little closer. Where'd my Google Earth Pro? Where should it go? Can't find it no more. Anyway. Come on, I don't want that. Okay. Strange. So let's go downtown LA. Go there. Let's get it clear. Here's downtown LA. Straight out to Palmdale. About 35 miles. About 35 miles. Okay. Whew. That's close. Both really close to that San Andreas Fault. But here we see, moving to the north, us and North America pretty much staying put mostly. And go ahead, use that diagram and draw your own transform boundary. Pause it, use the diagram right here, and draw your own. Here's a very cool, this is from the video, not from the video, but this was definitely in the video. We can see the fault line, the San Andreas Fault. These really interesting little kind of scars that come up on the side. And this, I believe, this is the Carrizo Plain. Really isolated area in between, you know, the Great Valleys, the great San Joaquin Valley, and basically the coastal areas. There's this Carrizo Plain. A lot of oil production in this area, but extremely sparse. That's where our San Fernando Valley is. Here's kind of a broader view of it. This is the Carrizo Plain, right here. You can see, I think that's the fault right there. But here's I-5, the little corridor over the I-5 and the Grapevine. And then, you know, here's, you know, Highway 101. So it's just right in between those. Lots of people here, lots of people here. You know, a large amount, but just really isolated on this area. This Soda Lake right there. I believe they talk about that a little bit in the video. Wish I could zoom a little more on that. Here's another cool picture. Just, you know, when you can see geology like that, so, you know, out in the open, that's pretty cool. But yeah, Carrizo Plain. right about there. In the video, we see that little spot, right south of San Francisco, where the fault comes back in. Just kind of moves right along our coast until, pretty much runs out there, the Salton Sea, Palm Springs, Coachella, which I'm sure you guys have heard of. Here, if you're going to Vegas, let's see, yeah, that's to Vegas here, I believe. On the 15, that San Andreas Fault goes right across. Talk about this lifeline corridors. I-15, huge. But also, as we'll see on this next one, this is I-5, the Grapevine, really close to the Grapevine. Yeah, no, try that again. This is north of Los Angeles, going to the San Joaquin Valley, Bakersfield. You see all this folding. That comes from, movement of tectonic plates and uplift. Uplift, movement of plates makes that. So if you do go on vacation or drive up north through the Grapevine, I'm expecting you to pay attention for this and then send me a picture. I'm sure you'll get some extra credit, or a gift card or something, if I see you using your knowledge in the world around us. I think this is cool. I mean, I would drive out here and be like, how did that happen? Look at that. These foldings go up, these go down. That's all from pushing up of those layers and then folding over in all sorts of crazy ways. Again, here's our Grapevine Summit. Here's our San Fernando Fault. San Andreas, that is. Running right through where these roads are. Here, you can see the San Andreas Fault running this way. And it cuts over right that way. And up here, this is another fault called the Garlock Fault that comes and joins it. This is actually, I think it was 1815 for Tahoe earthquake. It was a huge earthquake. So it was 1857, and it was magnitude 7.9 on the Richter scale, just pretty massive. The epicenter was actually a little bit north of here, but this is where this little settlement had the most damage. There wasn't a whole lot of settlement here, especially along the southern, or that area of the fault. But this is the nearest settlement that, as a major, area, way to get towards Los Angeles, there were buildings that were damaged. Oh, excuse me. Right here, this was the Llama Prieta earthquake in 1989. Llama Prieta earthquake, and it was a magnitude 6.9. And what you see here, this is the I-80 freeway just collapsed. And this is right in Oakland. You have this double-decker freeway, and it just sandwiched. These columns buckled. You can see that just snapped off, and then that top layer just crushed the bottom layer. And people were trapped. They were stuck in there. People were climbing up trying to get out. I remember the footage as a kid. Here's some more footage. I mean, just look at this. People trying to get out of there. This looks like a disaster movie, doesn't it? But yes, I was a kid then. I was in middle school, just starting high school, I guess, when that happened. This is a scene from Northridge. Earthquake in 1994. And let me check. This is a magnitude 6.7. And I even, pretty graphic. I mean, I think this person is somebody who was deceased. This kind of looks like a motorcycle that crashed. I don't know, this could be like a motorcycle cop that went off the edge from either side, but you see, this looks like it maybe, I don't know. This person looks like they're having, you know, a tough moment. Here's a car down here. Highly possible that person deceased as well. Just that whole freeway section just collapsed completely. And here you see in this complex interchange, you'll see a few sections broke down. But if you look, most of it stayed intact, especially like, look at this huge, long, high, that stayed intact, you know. One thing about this earthquake, most of the structures that were designed to withstand the earthquake did. Those that didn't, did not. Well, you'll see here, this is called a soft story collapse. And what I mean by a soft story is basically the first level is a parking garage. And you'll see these a lot. My first apartment that I lived in, and when I moved to Los Angeles, it was just like this. That lower story was a parking garage. And when that does, when it starts to shake, it just buckles. There's just so much weight on top, and you get it just starts to collapse. And then you can start having the other levels collapse once that momentum gets going. Now, you have an awesome map of this that you guys have been spending time coloring. So you should have, you know, a good, you know, fundamental understanding of where these plates are, where you're going to see earthquakes, volcanoes, hot spots that, you know, the Hawaiian Islands were created. You got a big divergent boundary here. You know, you got subduction zones, Central America, South America, and over on the western side of the Pacific. And if you remember, you might not remember 2005. That's before you were born, I think. Or no, some of you might have been born in 2005. There was a huge tsunami because there was a huge earthquake in this region, and that's created a huge tidal wave that took out killed a lot of people in Indonesia, Thailand, along the beach there. So definitely study the diagram. What I want you to do, answer these 3 questions. All right, you know, using this diagram, and you can also use the one you have yourself, the one that you colored up. Just another recent, I believe, you know, in the last 10 years. What causes earthquake? You know, just those two, just that tension, you know, between the plates and that buildup of energy, and then that shock when the tension is released, and then it reverberates through those plates. And this is a really classic one. Remember, we saw of the 1906 earthquake, or in San Francisco. When they investigated, they saw that fence line that broke just like this and moved 8 feet. Just very clear evidence that, you know, one part of the land is moving and the other part isn't. But just storing that elastic energy, bend and deform and stress until something breaks. So you just see it right here, just that bending, and then boom, all of a sudden it breaks, you have movement, and that gives you your earthquakes. So what I want you to do to finish this out, explain in your own words what an earthquake is, and, you know, feel free to use this information here or from the slide before. And that finishes up topic or 4.1.